それではそろそろお時間ですので、続いてのセッションに参りたいと思います。クラウド仮想化のトラックのですね、最後からの2つ目のセッションになります。続いてはスーパーマイクロさんからの、プレゼンテーションになります。それでは、Hi, ワンさん、リアンさん、please start your presentation.
All right, thanks. So hello everyone, welcome to this session. So this is the second session from Supermicro today. So my name is Ryan Wang, so I'm going to present how accelerating deploying GPU accelerated VDI applications. So with orchestration. So we are going to talk about how to expedite the speed up the deployment of grid VDI. Okay. So before we start, I just want to give you a short reminder. So we are going to have a thanks everyone stay so late because it's going to be the second one to the end. So if you we are going to have a lucky draw. So please make sure you drop your business card into a lottery box over there. So later we will draw a winner and you can try your luck. Yeah. And second one, I will finish this one in 20 minutes. So I will not get you guys late. Okay. So let's start. So I think as a GTC event today, so I think everyone should have known that there are new great GPU card from NVIDIA. So talking about VDI application side, I think everybody already having a lot of introduction about new M60 Grid 2.0 grid card for GPU-based VDI application. So basically, Grid 2.0 has a better performance. So you can see on the top left, so it's a better performance. So I am not going to spend too much time on that. I think everyone has more information than probably more than me from today's session. So from Supermicro, we also have a platform being ready to support latest Grid GPU card M60. So basically, we have 5 models under review by NVIDIA. So it will be soon posted on the website of NVIDIA, which is Grid certified server. So you can, I think this is an early version, but I think it's going to be posted on the website very soon. So basically, we have a lot of new model. A lot of model will support M60. So the special one is this one. This is 1U for GPU platform. So if you haven't seen that, actually our booth is just next to this wall on left side. So you can see this server, highest density currently, and 2 special features. That the first one, each GPU has direct airflow, so there will be no GPU behind another one getting preheated. So second one is that we support a low-cost GeForce card. So actually, if you see the design, each GPU card in between, there's a gap here. This is for GeForce graphic card connector because the GeForce connector is here. So while Tesla is here. So you need to have a room to plug into that power socket for supporting GeForce graphic card, GPU card. So with the GeForce, you can have make this high performance computing or grid VDI application server low cost, right? And next one, coming back to grid VDI application. So grid VDI application talking about twice performance, double performance. So it support twice amount of user, twice amount of performance, and twice amount of platform, including Blade server, and twice amount of OS, including Linux, right? So everything looks very fine, and high performance, great application. But is that really true? I think everyone in today's session will hear a lot about VDI application, especially GPU-based VDI application. So we have lots of certified servers and solutions there, but its implementation is that really easy. So I would like to just introduce actually it brings you double complexity in the implementation. So think about you have a double user to support, you have double platforms to manage, you have a double OS to manage too. So basically for IT, from IT management point of view, it's actually more complex. So we are going to introduce some solution for handling that complexity. So actually the VDI complexity is going to the next level right now with a newer hardware coming in and a newer technology. So that's before we talking about that solution. So we go back a little bit talking about the VDI infrastructure. So basically, this is plot showing this picture showing how VDI infrastructure looks like. So basically, the GPU is just right here. So GPU is only play a small role in entire VDI application. So besides of GPU, you still have a CPU, memory, storage, network need to take into consideration. Also, you could have a different form factor, right? You could have a rack server, or you could have a blade server, like it was just introduced in Grid 2.0. It supports double platforms, right? So here is a one level of complexity. And second level complexity is you have a multiple hypervisor to choose. You could choose, NVIDIA has a partner with a full hypervisor supplier, so you have a full choice here today, right? And then on top of that, then you have a different OS, right? So every level is generating twice complexity. So basically, you probably have a more than twice complexity to handle right now. So, but from the other axis, the other direction, horizontally, you can think about, you can look at, there is a CPU and a memory. So the CPU and memory are being virtualized by hypervisor into virtualized CPU and virtualized memory. The same thing for storage and network. So you have a lot of virtualized resource here. So you can kick off any virtual machine anytime, depends on requirement using the resource in the pool. And also you can decompose a virtual machine and put those resources back to the pool. So basically this is an advantage of virtualization. And second one is that you can run virtual machine for some specific task. And then you can have another backup virtual machine doing backup for that virtual machine. So once that virtual machine is dropping or is crashing, then you can have a second virtual machine coming up doing the failover things, right? So this is an advantage about virtualization. So so basically here, entire virtualization is virtualize the compute, storage, and network into this pool. So we take a resource from this pool to scope our virtual machine for real application, okay? And then from there, then you deliver the content into remotely to the clients located remote site, right? So you can use thin client or zero client or pad or mobile phone to look into your desktop remotely. So this is basically talking about the GPU accelerated VDI. So actually, I just want to mention that the GPU is just part of an entire structure. So it's a part of a resource to be virtualized. But besides of that, you have to consider about how you are going to pick up a good resource for VDI application. So going forward, that I'm going to introduce about from perspective of compute, storage, and network. So we will talk about here will be more hardware part. So we will introduce you our experiences on how we can accelerate the performance of hardware for VDI application. And second part we will be talking about software part, how you are going to use the latest software to manage the complexity of today's VDI application. So first thing is a CPU. So talking about CPU, so I think it's not strange to everyone. So actually today, most CPU are having multiple cores. So with a one processor, you could have N core, right? And then if you turn on the so-called hyper-threading technology, because most CPU today are coming from Intel, so we take an Intel CPU technology as an example today. So if you turn on the hyper-threading, you have a double amount of cores in a processor. And if you have a dual processor, then you have another double amount of cores in the system. And sometimes you could consider using four-way, meaning a full physical processor inside a system. So you can have 4 times of cores in a system. So which is helping you, the picture we just see that the more CPU resource you have, then you are able to virtualize them. So you are going to have a more CPU resource. So there's a one factor here is how you are able to choose the right hardware CPU to provide enough resource, CPU resource for your application. Second one is frequency. So basically, higher frequency will be better than lower frequency CPU. I have a chart. I have a table in the next slide to show you why is the testing results. So basically, higher frequency CPU will provide better performance to virtual VDI application than lower frequency. And the third one will be larger cache CPU will be better performance on VDI application to lower capacity of cache CPU. So here's a table. A test was done here that so the upper half, you could see we took a 2 CPU for comparison. One is a 2643, 4 cores, higher frequency, 3.3 gigahertz. And another one is 2665 and 8 cores. So this one has more cores but lower frequency. So we do some comparison, then it will tell you the things we just showed in the previous slide. So first one, talking about cores. So as the red color show 43 lower cores per processor. So you see actually it supports less VM than the other processor having more cores, right? So it's like a 1-to-2 ratio. So here is a 4-to-8, 1-to-2 ratio, and the number of a virtual machine is also 1-to-2 ratio. And second thing is that we talk about the number of a virtual machine per core can support. Meaning, if you take, for example, 2643 here, if you take this as an example, it's going up to somewhere 70. Right? So you take 70 divided by 4. So each one support like a 13 virtual machine. So you use that calculation and calculate. So actually 2643, although it has a lower cores, but it's running at a higher frequency. So it can support more virtual machine per core than that of a 65 here. So this is showing as a result that so if you have some real application, you can try to pick up a CPU with a higher frequency, which will be better for your application. So today, most VDI application are using Haswell CPU, so which is a V3 2600 series from Intel, and we will have a Browell coming in soon. So basically, it's going to be available Q1 next year, but there have been sample available right now for testing. So so let's just see what are feature advantages Broadwell bringing. So Broadwell has bringing 25% more cores per processor. That's the first thing. And second thing is that it has a more cache and also higher frequency, 2.5 gigahertz to memory. So basically, it's a fit to the entire VDI application requirement, right? We want more cores per processor and higher speed memory, higher speed CPU, higher frequency CPU, and also larger size cache, right? So Broadwell is definitely better than Haswell in VDI application. So one thing is that for Supermicro's system, right now we are all ready for Broadwell because it's pin compatible. And also what you need to do is just taking existing system update with the newer BIOS, and that's done. So then you can enjoy the advantage we just talked about. So here you can see with one single processor, you can have up to 88 cores here because you turn on hyper-threading and the dual processor is 88 cores, and it's 25% more than this one, 72 cores. So Broadwell is going to be I think a new trend for VDI application, which will be also good for GPU-based application. And another thing is the memory. So basically, you have to calculate enough memory for every virtual machine, right? So every virtual machine is configured 2 giga or 4 gigabyte, right? Then you have some then to get up together, with probably sometimes you need to have some buffer for some software leak, right? Sometimes some software has some memory leak problem, so just getting some buffer for that, right? So in this case, you have a 210 gigabyte required. And then hypervisor is require larger than a or larger than 8 gigabyte memory. So you sum them up. In this case, you need 218 gigabyte. So you probably want to prepare like 256 gigabyte in system for VDI application. So in case if every virtual machine memory going up to 4 gigabyte, and you probably want to double this amount to 512 gigabyte. So all of this need to be taken into consideration to provide a successful VDI application. Then we talk about storage. So another important factor will be storage. So IOPS means input-output operation per second. Okay. So basically, in VDI application, there's another thing you have to be aware of. That is, first one, VDI boot storm. And another one is a VDI steady state. So you have to really calculate, you need to know what is condition, what is a requirement for running all your virtual machine at the same time, right? If you put all the virtual machine at the same time, you probably will be required with like up to 40,000 IOPS, okay? And going to steady state is about 1,800 IOPS, right? So when virtual machine getting into steady, right? And then it requires 1,800 IOPS. So for first one, there are some methods can be solved. You can just put 10 by 10, right? Or 20 by 20, right? So you can solve this problem. You can lower down these IOPS, right? But for steady state, there's no room for trade-off, right? So basically, you have to meet this requirement. So today's storage media mostly are SATA, SAS, or SSD. Right, and also we have some new storage media called NVMe, which is a PCIe-based SSD storage. So basically, their IOPS being tested as listed as right-hand side here is for typical hard drive, it's like between 100 to 200 IOPS, and then SSD because it doesn't have a singular, right, and it doesn't need to spin the disk, right, and moving the reader, right? So SSD is much faster, like 5 times faster than the normal hard disk drive. Then it's about 1,000 IOPS, right? And NVMe is there's no layer, SATA layer or SAS layer, so it's going to PCIe directly, even faster. So it's going up to like 2,500, right? So you take this number and you divide this one. So for 1800 IOPS, then you need 18, because each one is 100 IOPS, right? So you need 18 hard disk drive to fit that requirement. But for SSD, you probably need only 2, right, for fitting 1800 IOPS, right? And for NVMe, you probably only need 1. So this is an advantage of the latest technology storage drive. So here's another example just based on this drive itself. So some Intel tests. So the one NVMe drive with this model, which is P3700, the IOPS for that is equal to 1314 hard disk drive. So think about entire space reduction. So you have a 2.5 rack reduced to be only 1 small drive. And second one is that you save a lot of power, right? So there brings some significant cost saving. Supermicro has also prepared a lot of NVMe platform ready. So one platform we show here is mainly for GPU application. So it accommodates 4 GPU in system and provide up to 10 NVMe drive, which provides significant IOPS for VDI application. So we have this unit also demo on our booth. Sorry. Also demo on our booth. So if you haven't seen this unit, you can just go our booth after this presentation. All right. And another one will be deduplication. So basically, every virtual machine has something similar, like Windows, Linux. They are actually very much similar to each other, and so you don't want to store LAN, per every virtual machine, right? So if you have a 100 virtual machine, everyone takes about 50 gigabytes, right? And total will be 5,000 gigabytes, which is a lot. But if you try to save only one golden image for OS, and you set up a 1 gigabyte for 100 VM each for the difference as a differential disk, right? Saving difference, then you can reduce entire storage space to 150 total. So which is compared to 5,000, it's a lot of cost saving. And so normally you have to consider block level storage, which is a SAN, right? Storage network. And another important thing is this network. So recently, I think we have some switch called software-defined network. So we run some software here, and from SDN controller, you can send a routing table remotely to update its routing table very quickly, and also some other routing parameters. So which brings a lot of advantage from traditional switch network, because traditional switch network, you have to go into each switch and change their routing table one by one, right? So SDN can help you to do those once. So think about you have 4, 200, 2,000, 20,000 switch in a network or in the data center. If you want to change their routing table, SDN controller is the right choice here. And last one, we talk about another level complexity. So you have a different OS to choose right now, because we agree the VDI application support Linux, and underneath you have a different hypervisor, right? So actually there's another level complexity we are not including today, which is for display protocol, right? So you have HDX, RDP and PCOIP, so you have to choose a different client for displaying those different protocol, right? So there are actually many things. So here is some solution coming in is we call OpenStack. So OpenStack provide is an open source software, so it provides you entire infrastructure, integrate all different type of hypervisor, and so you can deploy LAN in one single dashboard. So from dashboard, you can supervise a computer, which Nova, which is a compute for compute, for server, right? And then you can have a Swift and a Cinder for managing the storage at object storage, like file share storage or block level storage, right? And you can have a Neutron, which can control as a SDN controller to control your switch. And you have a ID controller, right? The user ID identification. So basically, it's fit to compute, network, and the storage architecture. So basically, if you're talking about Citrix, Citrix is one of NVIDIA selected partner for hypervisor. So from there, you can use OpenStack, which is we have today is a Mirantis software that can support you on dashboard, orchestration, compute storage network, right? So you can deploy as we just introduced. And also, there's another solution will be coming from Microsoft, which is using SCVNN, which is a System Center Virtual Machine Manager. So you can configure your Hyper-V and Microsoft storage and Hyper-V network virtualization, right? And also you can have a VMware too. So VMware, I'm going to just quickly go over vSAN and also our Mirantis solution here, because I think with a vSAN, then you add up a network, and then you can use so-called VIO, which is VMware integrated OpenStack for free. So Supermicro has been partnered with Mirantis, and is working with Red Hat and Canonical Ubuntu to formulate this solution. So one example is like this. What we have today is from Mirantis, and you have a compute node, right? You have a storage node, you have a switch, and also you can deploy Mirantis OS, which is called Fuel. So you have a one rack solution and complete, and then you can easily deploy VDI quickly. And last one will be vSAN. So vSAN, basically, every cluster is composed of at least 3 nodes, right? And maximum 64 nodes. So all the compute and the storage can be shared within a cluster. So we also have a vSAN solution ready, which is certified by VMware. And so with 4 nodes, you can support up to 200 virtual machines, and which support graphic GPU application as well. So basically, these are all successful cases in the field, right? And then we have what we are working today is that we can accept requests, and we do consulting on your request, and we provide solution, and then we do integration of the system, and then we test them, and we deliver to our customer. And also we do service 724, and we have a level 1 to level 3 support for the solution we delivered, right? So that's my today's presentation. So I just want to, if you have any question, then just feel free after the session. So I just want to take 1 minute to draw a lucky winner for our small gift quickly.